Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hydration of alkynes with HgSO4 dil. H2SO4, Markovnikov addition of water, converts alkynes to carbonyl compounds, ketones or aldehydes. Reduction of a ketone with Lyell-4 produces a secondary alcohol, which can be chiral and thus form a racemic mixture. Moving on to the next step. The final product, C, is a racemic mixture, meaning it contains a chiral center. A racemic mixture is formed when a prochiral carbonyl compound, specifically a ketone with two different alkyl groups, is reduced by Lyell-4, which attacks from both faces of the carbonyl equally, producing equal amounts of R and S enantiomers. Moving on to the next step. For B to give a racemic mixture upon Lyell-4 reduction, B must be a ketone with two different groups on either side of the carbonyl, i.e., an unsymmetrical ketone. Reduction of an aldehyde gives a primary alcohol, only one H and one alkyl group on the carbon. Actually, it does give a chiral center if the resulting alcohol is chiral, but let's check each option. And for the final step, evaluate each option for hydration product B. A. CH3CCH, propyne Markovnikov hydration gives CH3-CH3 acetone, a symmetrical ketone. Reduction gives to propanol which has no chiral center, no racemic mixture. B. HCCH, acetylene hydration gives CH3-CHO, acetaldehyde, an aldehyde. Reduction gives ethanol, no chiral center, no racemic mixture. C. CH3CCCH3, to butene Markovnikov hydration gives CH3-CH2CH3. Wait, actually for an internal symmetric alkyne, hydration gives CH3-CH2CH3. No, to butene is symmetric, so hydration gives CH3C is equal to O, CH2CH3. Actually to butene hydration gives butanone, CH3-COH to CH3, an unsymmetrical ketone. Lyell-4 reduction of butanone gives to butanol, CH3CH of CH2CH3, which has a chiral center at C2. Since Lyell-4 is achiral and attacks both faces, it gives a racemic mixture of R and S to butanol. This matches the condition. D. PHCH is equal to CH2, styrene. This is an alkene, not an alkyne, and HgSO4 dil. H2SO4 is used for alkyne hydration. Even if it reacted, it would give PHCH or CH3 directly or PHCOCH3, but styrene is not an alkyne. Why not option A? Propyne gives acetone, symmetric ketone, to propanol has no chiral center, no racemic mixture possible. Why not option B? Acetylene gives acetaldehyde ethanol, no chirality. Why not option D? Styrene is an alkene, not an alkyne. HgSO4 dil. H2SO4 is specific for alkynes. Option C. CH3CCCH3, to butene, hydration gives butanone, methyl ethyl ketone. Lyell-4 reduction gives racemic to butanol. This perfectly matches all the given conditions. Therefore, the correct answer is C. Therefore, the correct answer is option C.